From the fiery heart of our sun, this powerful force known as the solar wind stretches out, shaping every corner of our solar system. But what exactly is this invisible force, and how does it affect the world around us? The solar wind starts here on the sun's scorching outer atmosphere, the corona. The sun's corona is an inferno, with temperatures reaching millions of degrees. At this heat, charged particles like electrons and protons become so energized that they break free. The solar wind can be classified into two main types based on speed and origin. The fast solar wind, which races outwards at speeds up to 800 kilometers per second, originates from coronal holes, while the slow solar wind, moving at about 400 kilometers per second, comes from the sun's equatorial regions. Imagine the solar wind as the sun's extended touch, reaching out and interacting with every celestial body in its path. Comets, those icy travelers of our solar system, are dramatically affected by this wind. As a comet orbits closer to the sun, this solar wind begins to interact with the comet's nucleus, leading to a spectacular display. The sun's warmth causes the ices in the comet to sublimate, turning directly into gas. This process releases dust particles that were once trapped in the icy nucleus. When the solar wind encounters this cloud of gas and dust, it ionizes or charges the gas particles. And just like iron filings responding to a magnet, these charged particles align with the magnetic fields carried by the solar wind. This interaction gives rise to the comet's dual tails. The dust tail, a brilliant curved trail, reflects sunlight and appears yellowish white. The ion tail, composed of charged gas molecules, interacts more directly with the solar wind and always points directly away from the sun. This tail emits a bluish hue due to ionized carbon monoxide and other molecules. An intriguing dance ensues. No matter which direction the comet is moving, its ion tail always aligns with the solar wind, pointing away from the sun, while the dust tail curves along the comet's path. For ancient civilizations, the dramatic tails of comets, shaped in part by the solar wind, were often seen as omens or messengers from the heavens. Today, they stand as testaments to the intricate ballet of cosmic forces at play. Back home on Earth, our planet's magnetic field acts like a protective shield and deflects many of these charged particles, but some do get through, and the result? The breathtaking auroras, or the northern and southern lights. These mesmerizing light shows are the result of particles from the solar wind colliding with our atmosphere, exciting gases and causing them to emit beautiful colors. Yet the dance of the solar wind with Earth's magnetosphere isn't always just about celestial beauty. At times, intense bursts of solar wind can create geomagnetic storms. These storms can induce electric currents in our power lines, causing voltage instability. The result? Potential blackouts affecting our cities, our homes, and our daily lives. Our modern world, interconnected by satellites, isn't immune either. The solar wind can interfere with satellite operations, affecting everything from communication signals to your GPS directions. But this wind also plays a role in maintaining the ionosphere, a layer of Earth's atmosphere. This layer is crucial for radio wave propagation, allowing for long-distance communication. On a fundamental level, the solar wind, by influencing Earth's magnetic field, has possibly played a role in shaping life as we know it. From the DNA's protective mechanisms against radiation to the evolutionary paths of species, the solar wind's subtle touch is ever present. What about solar wind's impact on Mars? While Earth dances with the solar wind, shielded by its magnetic embrace, Mars tells a different story. A tale of a planet once wet, now dry, with the solar wind playing a starring role. The red planet lacks a strong global magnetic field. Without this protective shield, the solar wind has direct access to the Martian atmosphere. Over billions of years, this continuous barrage has siphoned off Mars' atmosphere atom by atom. Lighter molecules like hydrogen are the first to be swept away, a process that has profound implications. Many scientists believe that Mars was once home to vast oceans and rivers, but as the solar wind eroded its atmosphere, the planet lost its ability to support liquid water on its surface. Unlike Earth's consistent magnetic shield, Mars has patches of local magnetic fields, remnants from an ancient era. These fields create pockets of protection, but they're far from a global shield. The disparity between Earth's robust magnetic defense and Mars's fragmented one showcases two different evolutionary paths, shaped in part by the solar wind. Today, as we send rovers and satellites to explore the Martian terrain, understanding the solar wind's influence becomes even more crucial. It helps us decode Mars's past and prepare for future manned missions. The solar wind doesn't flow uniformly. Just as our earthly winds vary in intensity, the solar wind ebbs and flows, influenced by the sun's moods and cycles. During periods of high solar activity, like when there are more sunspots or solar flares, the solar wind can become stronger, denser, and faster. At quieter times, it's more like a gentle breeze. The intensity and frequency of solar wind gusts are linked to the 11-year solar cycle. During solar maximum, when sunspot activity is high, the sun emits more intense solar wind and more frequent coronal mass ejections. This dynamic stream carries the sun's magnetic field outward, expanding its influence far beyond the planets until it encounters the interstellar medium, the matter between stars. And here, a grand cosmic boundary forms, the heliosphere. Imagine it as a vast protective bubble surrounding our entire solar system, sculpted and maintained by the solar wind. But this boundary isn't a static wall. It's a dynamic, ever-shifting frontier where the solar wind collides with the interstellar medium. The point where the outward push of the solar wind balances the inward pressure from interstellar space is called the heliopause. Our understanding of the heliosphere took a leap when the Voyager spacecraft crossed this boundary. They sent back data from the edge, giving us invaluable insights into this distant frontier. As solar wind particles near the heliopause, they slow down, accumulating in a region known as the heliosheath. Some particles get turned back by the interstellar medium, creating a turbulent zone. Ahead of the heliosphere, as our solar system cruises through the Milky Way, there's a bow shock, much like the bow wave in front of a ship. This is where the heliosphere's nose plows through the interstellar medium. The scale of the heliosphere is immense. From its heart near the sun to its outer boundaries, it extends billions of miles, enveloping all planets, asteroids, and even the distant realm of comets. This cosmic bubble, the heliosphere, is our home in the vastness of the universe. It's a testament to the sun's influence, shaping the environment of our solar system and guarding us from interstellar space. The solar wind is an ever-present sculptor, silently molding the cosmic ballet around us. The universe is full of wonders waiting to be explored. Dive in with us for more celestial stories. Don't forget to watch the video on the right and subscribe. Thanks for being part of Cosmoknowledge.